Okay, let's look at finding the slope of another function here. So we're going to be finding the derivative, the slope function of the function 1 over x. And I looked up number 8 just to compare later. We found that was -1. Okay, so what is the derivative? Let me start again with that. In this case, my function is defined as y equals. So I can use the notation y prime. We're going to be talking about notations in a couple videos from now. So for right now, we'll just stick with that prime notation. So I'm going to be taking x plus delta x and putting that into the function minus the original function itself, just f of x, all over delta x. Okay, so this is similar to number 8 where we need a common denominator. But in this case, the denominator of this one isn't just 1. So this one has a denominator of x. This one has a denominator of x plus delta x. So as a little side note, think about this if you're confused about this. So say I asked you to do something like, what is 1/5 minus 1/3, right? To get a common denominator, you'd say, oh, I'm going to multiply this fraction by 3 over 3 and this fraction by 5 over 5. So this one would be 3/15, this one would be 5/15, and you'd subtract and get your -2/15, right? So you would multiply by the other person's denominator, right? Okay, so what I mean by that is over here, I'm going to want to multiply by x plus delta x over itself. And this one I'm going to multiply by x over x. Now, why are we allowed to do this? Of course, it's because in all 4 of these cases, we're just multiplying by 1. And multiplying by 1 does not change the value of the expression. So we're not doing anything wrong here. Algebraically, this is fine. Okay, so in this first expression, I have x over x times x plus delta x, right? My original x. Don't cancel them here. That's silly. You'd be going in circles. The whole purpose is we want the common denominator. And then over here, we have x plus delta x, right, my numerator. Again, I'm going to think about that in parentheses because later I'm going to have to distribute this negative. Okay, and again, don't cancel these x plus delta x's. That will undo what you literally just did. Okay, the goal instead is to actually subtract these two things, right? Now these have a common denominator. Okay, so what is this equal to? This is in the numerator. I'm taking x. So think about this, right? We finally got a common denominator. So now we actually just subtract 3 minus 5. Or in this case, x minus x plus delta x. So x minus, when I subtract x plus delta x, the x is being subtracted and the delta x is being subtracted. In the denominator, I'm left with x times x plus delta x. Now, this whole thing is over delta x, but we talked about in an earlier video when we talked about number 8, we talked about how that's equivalent to dividing by delta x here. Okay, so in other words, we can bring this delta x up into this one's denominator, and that's just using middle school division of fraction rules. Okay, so now let's look at this expression we have. We do have x minus x that we can simplify, so we're going to cancel and look at what's left. We're left with the limit as delta x goes to 0 of negative delta x over x plus delta x, delta x. So see, we have this common factor of delta x, and at this moment I'm allowed to cancel, but only because I'm writing the limit every time. So at this equal sign right here is only actually a real equal sign if I remember to write that limit. And I'm left with just -1 over x times x plus delta x. Okay, direct substitution. What happens now as delta x goes to 0? I'm left with just x times x in the denominator, so -1 over x squared. This is my derivative function, or y prime. Okay, there we go. We took the derivative. The derivative of 1 over x is -1 over x squared. Let's compare this answer to what we got for particular values, right? So f prime of 1 is what number 8 was asking us to do. According to our function, this would be -1 over 1 squared. So that's -1, and that confirms what we got in the previous problem, right? So think about the graph of y equals 1 over x. This sketch is not so good. At +1, we had a slope of -1. That makes sense. But I could very quickly find other ones, like say I want to find f prime at I don't know, -5. So that's going to be -1 over -5 squared. That's -1 over 25. So I look way over here at -5. It makes sense that that's a pretty shallow negative slope, right? So this slope function will take in as input any input x we want, and it will output the slope of the function at that point.